With ARM technologies, we provide the best solution. The linear actuators. Imagine a world where production linear actuators are revolutionizing motion by turning rotational energy into precise, controlled movement. From robotics to industrial systems, they enable smooth, accurate operations, making them essential for modern automation and innovation. How linear actuators work. Linear actuators typically use motors that rotate a screw or threaded rod. As the motor turns, a nut or similar component moves along the length of the screw, converting the rotation into forward or backward linear movement. This mechanism provides precise control of the position and speed of the actuator. Why you need to use linear actuators. Linear actuators are essential for many industries because they provide precise, reliable, and controlled motion in applications requiring linear movement. 1. Precise motion control. Linear actuators offer highly accurate positioning, making them ideal for tasks that require precise movement, such as robotic arms, medical devices, and automated machinery.
2. Automation and efficiency. They allow for automation of repetitive tasks, improving speed and productivity. In manufacturing, for example, linear actuators streamline operations by moving objects consistently and efficiently.
3. Handling heavy loads. Hydraulic and pneumatic linear actuators are particularly useful for heavy-duty applications. They can lift, push, or pull heavy loads that would be difficult or impossible for human operators or smaller machines to handle.
4. Compact and space-saving. Linear actuators provide powerful motion in a relatively compact size, making them ideal for applications where space is limited, such as in medical equipment, aerospace systems, or compact machinery.
5. Durability and reliability. Many linear actuators are built to withstand harsh environments, including extreme temperatures, moisture, and dust, making them reliable for industrial and outdoor applications.
6. Low maintenance. Compared to hydraulic or pneumatic systems, electric linear actuators typically require less maintenance because they don't involve fluid systems or complex mechanical components, leading to lower operating costs over time.
7. Versatility. Linear actuators are used across many industries, including automotive, aerospace, healthcare, manufacturing, and renewable energy. Their adaptability allows them to be integrated into various systems for different purposes.
8. Energy efficiency. Electric linear actuators are energy efficient compared to other motion systems like hydraulics. They only use energy when in motion, which can lead to significant energy savings, especially in automated systems.
9. Enhanced safety. Using linear actuators for heavy lifting, dangerous tasks, or high-precision applications reduces the risk of injury and accidents by replacing manual labor with automated, safe mechanical movements.
10. Environmental friendliness. Electric actuators, in particular, operate without oils or fluids, making them a cleaner option for environments requiring high standards of cleanliness, such as food processing, pharmaceuticals, and laboratories.
Types of linear actuators. 1. Electric linear actuators. Its work powered by electric motors. They use either a lead screw or ball screw to convert rotational energy into linear motion.
What are the advantages?
The advantages are high precision, easy control, low maintenance, and cleaner than hydraulic or pneumatic systems.
Example of applications.
Automation, robotics, medical devices, automotive systems, and adjustable furniture. 2. Hydraulic linear actuators.
How its work.
Its work powered by pressurized fluid that moves a piston to create linear motion.
What are the advantages?
The advantages can handle very high force loads and are highly reliable in rugged environments.
Example of applications.
Heavy-duty machinery, construction equipment, and industrial presses. 3. Pneumatic linear actuators.
How its work.
Its work use compressed air to move a piston inside a cylinder, creating linear motion.
What are the advantages?
The advantages are quick movement, cost-effective for simple applications, and can be used in explosive environments.
Example of applications.
Food processing, pharmaceutical manufacturing, material handling, and automation systems. 4. Stepper motor linear actuators.
How its work.
Its work by a stepper motor drives the linear motion, with each pulse of electricity moving the actuator in precise increments.
What are the advantages?
The advantages are high precision and easy integration with control systems.
Example of applications.
3D printers, CNC machines, and positioning systems. The evolution of linear actuators continues as advancements in materials, electronics, and control systems improve their efficiency, precision, and reliability. Future trends include greater integration with artificial intelligence (AI) for predictive maintenance, further miniaturization for use in compact devices, and enhanced energy efficiency to meet sustainability goals.
Thank you for watching. For more knowledge about actuators and spare parts of robotics, don't forget to subscribe, like, and share.